Hey y'all, Dan from Inngest here with a quick demo to show off how to solve concurrency issues in multi-tenant systems. So we get this question a lot where folks are looking to solve these issues around queuing in multi-tenant systems that they're building, and specifically a lot around noisy neighbor issues. So I built this demo to visualize this. So let's just jump in. So let's say you have a simple job queue, right? It's first in, first out. So users can trigger jobs to run and they will be processed roughly in that order. Great, awesome. But what happens if one user sends a bunch of jobs? Okay, so now this user is blocking the other user's work. So the challenge with this is now these other users are having a bad experience, right? They're waiting, they're sitting around because one user's consuming a lot of resources or is ahead of them. So no one likes to wait. Users are going to be unhappy. Ideally, you can build systems where no one user can block another user's work, right? They shouldn't have to pay the costs. It's hard to do, but it's the thing that we aspire to. So what if we could put each user in their own queue and limit each user how much they can use? So let's see what we can do with that. This is an ingest function, and it has a concurrency limit of 1, as you can see here. So what we can add is a key. I'll talk about what this means. So when we add a key to this concurrency limit, Inngest applies this limit to each unique value of this key. So I'll save this file right here. And for our system, we use a user slug. Your system could be an account ID, it could be a user ID, it could be some combination of multiple different types of keys. And it applies that limit for each unique value. So as new values of these keys happen, Inngest dynamically spreads these things out into basically their own queue and applies that limit. So let's see what effect this has. So let's go back here, clear all the jobs, and let's just everybody gets a ton of work and dumps all these different things. So now you can see that each user is not blocking each other. Each user has their own concurrency limit applied and each user is isolated. No one is blocking anybody else. So this is creating a system where a noisy neighbor can't disrupt anything. So this is basically in and of itself just like an easy way that you can drop one line of code with Inngest to solve these types of problems. Of course, in your system, hopefully your limits might be higher than 1, but you also might need to apply a global limit. With Inngest, you can actually combine multiple limits. So let's say you had a limit of 1 per user and a global limit of 2 or 20. You could apply those limits and Inngest will combine both of them to make sure that your system only processes, in this case, 1 job concurrently per user and 20 total jobs at a given time across all users. So this type of thing is typically pretty difficult to do in a lot of systems. You'd have to stand up a queue per user, or you might have to know all your user IDs ahead of time, or figure out some sort of resource allocation and distribute load. It's possible, it's a pain. So what we aim to do is make this possible with just adding a single line of code. And if you like this, you can actually combine it with other methods of flow control, which I might cover in other videos, like prioritization. So some users with different plans could jump ahead of other users. You can combine these types of flow control in interesting ways to get the system that you need in just a few lines of config, all on a per function basis. So thanks for watching, and if you want to learn more, check out the concurrency docs and other docs on flow control. I'll link below. Thanks for watching.